So this is going to be a surprise then. This will be the first video I've done where you get to see my ugly face and listen to my horrible voice. We'll see how this goes. Some of you may not know who I am. I'm not going to give my name away. It's really, well, not difficult to find out, but it's not important. My online presence is deckingman, because when I started 3D printing I had a decking business at the time. People used to phone me up and say, "Is that the deckingman?" So when I was looking for a username I came up with deckingman. I'm actually an engineer by training. Most of my life was spent in engineering one way or another. I'm now retired. I'm not going to tell you how old I am either. I was born in the year of the coronation of our present Queen, Queen Elizabeth II, so you can work it out from there if you want. So just to clear a couple of things up, I'm not actually affiliated with Duet in any way. People sometimes think I am because they've seen my machine on the stand at the TCT show. Might even have seen me wearing a Duet polo shirt. But the thing is, I've always had an interest in colour printing, and I used to run a 3-colour diamond hot end, and in 2017 the Duet guys approached me and asked if I would mind them having my printer on their stand at the TCT show, which was very flattering. And at the time reprap.me had just brought out a 5-colour diamond, so they said it'd be really cool if it was 5-colour. The outcome was they helped me out with the hardware in terms of a couple of extra extruders. reprap.me actually donated my first 5-colour diamond. I've bought several since then. I already had the Duet main board and the Duet expansion board and a couple of daughter boards and the infrared sensor and a few other bits and bobs. So they basically helped me out with the hardware to do that conversion, and then I took a week out of my day job, took the printer apart, took it up to the NEC and spent 3 days on their show and brought it back down. So that was the deal. I think yeah, I think they got the better part of the deal, but there we are. And then again in 2019 the Duet guys bought out the Generation 3 electronics, and again they approached me and said, you know, do you fancy helping us out? In return we will give you the boards, which they did. So I didn't pay them any money for the Generation 3 boards. I bought the cables and connectors and again did the conversion myself and so forth, and again spent a week at the TCT show with the machine on their stand. It was a bit of embarrassment, if I'm honest, because the firmware wasn't ready and I couldn't even home the printer properly, let alone do a successful print. We got squirted some plastic out and managed to show off the boards, although it was more of a static demo than a working one. Those are prototype boards. I obviously didn't earn enough brownie points to get proper ones, so these are prototypes. They're okay. They seem to function. They do everything mostly. I just have to remember some of the dip switches are upside down, and there's a fault on the expansion board, so I could not run the temperature sensor daughter boards, so I can't run PT100s or thermocouples. So I'm stuck with the misters, but other than that they seem to work. They seem to be doing everything that a production board would do, apart from those 2 foibles. So that's the sum total of my relationship with the Duet guys. I have a blog channel and I document everything that I do on there mostly. The videos I've made today have just been me showing off, to be honest. So I'm just an end user of Duet products. I had the first the 06 board they used on the reprap Pro Mendel, which was my very first printer. and I converted it to the tricolour version, which needed the expansion board, which was called a Shield in those days. And then I've had Duet 2 Wi-Fi and then Ethernet, and now I've got the Generation 3. And I spend quite a fair bit of time, or have done in the past, on the forum, just helping out other users really. So I guess probably what I need to do is just explain a bit about my crazy invention of a printer. So I'm going to step aside and pan the camera down and carry on talking, and we'll just see how this goes. So this is the beast itself, and the base is down there on the floor, so that's effectively the Z-axis, and then about a meter above that we come to there, and so this is the hot end gantry. It's currently fitted with a 6 input experimental hot end that I'm trying to develop. I've always had an interest in colour printing, so I've always used mixing hot ends, and the printer was kind of always designed to have that kind of an arrangement, a big multi-input kind of heavy hot end. So, and it's a CoreXY, that's the X motor, that's the Y motor. In actual fact they're called alpha and beta, but we'll call them X and Y for the purpose of this video. The printer was always designed to be used with a mixing hot end, which are big, and they have multiple inputs. Now if I had put the extruders on the frame is 600mm square, so to reach every corner of the bed I would have needed Bowden tubes about at least a meter long, if not more. You can't have direct drive extruders on a mixing hot end because there just isn't room to fit them in. If there was, the hot end would be massively big, and you'd have very little travel in X and Y unless you made the printer massively wide. So the extruders are remote, and as I say, if they were on the frame, then I would have more than a meter of Bowden tube, which ain't going to work very well. So I went through various configurations, and the printer has evolved into having this arrangement now. So this is my 6 extruders. You can easily see 4, there's 2 more around the other side. There's 6 Vontech BMGs, and they're basically mounted on another CoreXY gantry. So these 2 motors get mapped together, and they're both the X-axis motors, and then these 2 motors are mapped together to the Y-axis. So it's still a CoreXY, but it has 2 gantries which move in perfect sync because the motors get exactly the same signals. But there's a little problem with that, because if I do that and then I tried to home the printer, the upper gantry is going to crash into the frame before the bottom gantry reaches the edge. So for homing, the motors are individually mapped to each gantry, and the lower gantry becomes the XY gantry and the upper gantry becomes the UV gantry. So for homing it is a CoreXY UV. You may have come across those kinematics. This was the world's first, and the guys at Duet actually wrote the CoreXY UV kinematics for this machine to allow me to home those axes independently. So they've both got their own end stop switches. although the first moves, they have to move together. Otherwise it would just tear the Bowden tubes out of the clips. So they move in sync until one or other gantry reaches its end stop, and then the other gantry carries on moving until it reaches its end stop. That's kind of roughly how it all works. So the mass of the hot end gantry is around 2 kilograms, and the mass of the extruder gantry with 6 extruders and the expansion boards, which we'll come to later, is around 3 kilograms. In fact, it's more than that now. So the total moving mass in the Y direction is over 5 kilograms. And I print at quite high speeds, or have done. I have printed at 300 millisecond. My default travel speed is 350 millisecond. I use that all the time anyway. So when you start throwing 5 kilograms around at those sort of speeds, the entire printer rocks around because it's quite top heavy. So I did a bit of a crazy thing, and it doesn't have any impact on print quality. It just stops the printer rocking around and looking quite as alarming as it did. And that is, I've added yet another CoreXY gantry, which is this upper one. Again, it's got an X motor and a Y motor. And the carriage contains nothing more than lumps of lead. But the motors are reversed. So again, when it's printing, that is another X motor, so there are 3 motors on the X axis and 3 on the Y axis, but that one's reversed. That one's reversed. So whatever the hot end and extruder gantry does, this upper one does the opposite. So it basically does that and cancels out all the forces. And again, it needs to be homed separately, because I can put it anywhere, and then if I was to home it, it's going to crash against the frame or the other axes or whatever. It's going to get messy. So that is its own homing switches. For homing, then that is called the AB axis. So it's progressed from a CoreXY to a CoreXYUV to a CoreXYUVAB. Now, most of the alphabet, but that's what it's all about.